Okay, here we go with a second example. So this is straight out of the book. This is activity 6.2.1a. And what we would like to solve is x double prime plus 4x prime minus 21 equals, 21x, sorry, equals 2e to the 4t, and we're told x of 0 is 1 and x prime of 0 is 0. So here we have this forcing function on the right hand side, and actually this is kind of one place where Laplace transforms come in very handy, or with some different forcing functions. And so we need to take the Laplace transform of everything. So when I do that, I have the Laplace transform of x double prime. I'm going to use the linearity properties here. So 4 Laplace transform of x prime minus 21 times the Laplace transform of x. And that needs to equal 2 times the Laplace transform of e to the 4t. So now, using my theorem, I know this is, and now my x's here, they're going to be uppercase x's. It's going to be hard to tell the difference, but so there's, I need s squared times that Laplace transform of x, and then minus, and remember the s's go down, so s, and this would be x, little x of 0, and then minus x prime of 0. So there's some initial conditions there, plus 4 times, remember your parenthesis, I've got x, s times capital X, Laplace transform, and then minus just the x of 0, and then minus 21 Laplace transform of x, and then that equals 2. And now I have to look up in the table, but the table says, so I just look in a handy table. I'm going to look at it right this moment. I'm sorry you can't see it. But in the table I put online on Blackboard, it is number 2, e to the at, and so that's 1 over s minus a. Well, a here was, what the heck is it, 4? So I get this. All right, now I want to substitute in for my initial conditions and collect all my x terms. So I'm going to have x times, and I have an s squared from here, so that's taken care of. Here is a 4sx, so plus 4s, so that term's taken care of. And then a minus 21. Now notice, that's just our characteristic polynomial from chapter 4. So, there are definite relationships here. I mean, we're solving the same differential equation. There should be some things that are very similar. And so that takes care of the x's. And then minus x of 0 is 1, so minus s. X prime of 0 is 0, so nothing there. And then minus 4 times 1. So that took care of that. I've gotten that. I have everything on this side, I believe. And so that equals 2 over s minus 4. And so now I can move the s and the 4 over, so I have x times my polynomial there, s squared plus 4s minus 21 is equal to s plus 4 plus 2 over s minus 4. So all this is great. Now here's where it gets mighty ugly. Now I could, why don't I take one more step and I can factor this thing. So this is x times s plus 7 times s minus 3. So that's nice of the book to give me something I can factor easily. And equals my right-hand side, s plus 4 plus 2 over s minus 4. And so now I solve for that Laplace transform x. And I get s over s plus 7, s minus 3, plus 4 over s plus 7, s minus 3, plus 2 over s minus 4, s plus 7, s minus 3. So I have a bunch of partial fractions to do. Now what I'm going to do, I'm going to try here is add another page, click that, so I can go back here and see these. Okay, I'm going to do these one at a time. So I have the s plus 7, s minus 3 over s. And so I have s over s plus 7, s minus 3. And I need to write that as sum a over s plus 7 plus b over s minus 3. And so what I know is that the numerator, so s has to be a times s minus 3 plus b times s plus 7. And I am going to just choose some nice s's. So if I let s equal 3, I get 3 equals b times 10. And so I know right away that b equals 3/10. And if I let s equal negative 7, I have negative 7 equals a times negative 10. Oh, that's interesting. So a is equal to 7/10. Okay, so there's my first partial fraction. And so in that case, what I have is, I'll write it over here, I guess, 7 over 10 times s plus 7 and plus 3 over 10 times s minus 3. Okay, so I have that one. Going back here. Oh, come on. Okay, now I have a 4 over all that, so I'll go back, and that's similar to this. I have 4 over s plus 7, s minus 3. That also needs to be sum a over s plus 7 and plus b over s minus 3. I do go about it the same way. I have 4 is equal to a times s minus 3 plus b times s plus 7. Again, if I let s equal 3, in this case I get 4 because that doesn't change. B times 10. So here I have b equals 4/10. And if I let s equal negative 7, I get 4 equals a times negative 10. So a equals negative 4/10. So at this point, I have for that fraction, I have, as I wrote it out here, let's see, what is that? A is -4. So I have -4 over 10 s plus 7, and then plus 4 over 10 s minus 3. So that was the result of those two. Now actually, I can put these two together. So at this point, those two things together make a partial fraction of, and I could have done it all at once, I suppose, but I have 3 over 10 times s plus 7, and 3 plus 4, so that's 7, so plus 7 over 10 times s minus 3. Okay, I'm going to pause for a